What is differentiation? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. In mathematics, process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. There are different techniques of differentiation: the first derivative principle, constant rule, power rule, sums and differences rule, product rule, quotient rule, chain rule, derivatives of trigonometric functions, derivatives of exponential functions, derivatives of natural logarithmic functions, and implicit differentiation.
You might be thinking, what kind of daily problems that uses differentiation? But you'll be surprised as to how many problems that actually need solving by using differentiation. Differentiation has a remarkable ability to predict the world around us and can also describe exponential growth. For an example, we can use much complicated differentiation to model the relationship between the lifespan of predators and prey. Differentiation can also be used in a variety of disciplines. For example, in medicine, differentiation is used to model cancer growth or the spread of a disease, while for engineering, it is used to describe the movement of electricity.
How differentiation helps to solve daily problems. First, differentiation helps to calculate the profit and loss in business using the graph. Basically, it is used for business companies to help and facilitate them calculate the sales stock and losses they have to face. Secondly, differentiation helps to check the temperature in variation to more identify the ambient most accurately. That is, to determine the speed or distance covered, such as miles per hour and kilometers per hour. It helps the car riders to find out and compare their speed with the opponent. Fourth is to derive equation in physics. And lastly, differentiation helps to find the range of magnitude of the earthquake to help those who work as weather forecasters to know the state of Earth. Is it differentiation is important? The answer is yes. Differentiation is important for business companies. Differentiation also helps the seller to contrast its own product with competing products in the market and emphasize the unique. The goal of product differentiation is to create a competitive advantage and to make your product superior to alternatives on the market. It's so important, it contributes to the buyer's perception of no substitute being available.
Now, let's talk about the problem statement. Lisa has a rectangular piece of paper with a perimeter of 50 cm. She wants to use that piece of paper to build an open cylinder at both ends. Find the length and width in centimeter of piece of paper that makes the volume of cylinder a maximum. Here are some keywords: rectangular piece of paper, perimeter of rectangular paper 50 cm, volume of cylinder, V equals to pi r square h, and volume of cylinder at maximum, d square y over dx square, less than 0.
To solve the problem, there are exactly two parts. Part 1, deriving formula by substituting. To understand better, draw out a rectangle. Label the rectangle as follows. Say that the length of rectangle is x and the width of rectangle is y. It is stated that the perimeter of the rectangle is 50 cm. Thus, adding up all the sides of the rectangle, you shall end up with the equation 2x plus 2y equals to 50. It is also stated that the cylinder is open-ended. Hence, when sketching out the net surface, you will be left with a rectangle. Thus, let the diameter of the net surface of open-ended cylinder be 2 times radius and the height of the cylinder be h. Again, to understand better, sketch a cylinder. As you can see in the diagram, the radius of the cylinder is half the diameter and the height is h. Therefore, the diameter d represents x and the height h represents y. Thus, by rearranging the equation d in terms of x, or in other words, the equation x equals to 2r in terms of x, the radius shall now be x over 2. By rearranging the equation 2x plus 2y equals to 50 in terms of x, y shall now be 25 minus x. Now, to derive the formula of the open-ended cylinder with the given information, the values of r and h is substituted in the volume. Note that the radius is half of x and the height is y, which is 25 minus x. The volume of the cylinder is calculated with the formula pi r square h. Thus, by substituting the values of r and h respectively, the simplified volume of cylinder in terms of x shall now be displayed on the screen. Moving on to part 2 of the solution, differentiating the volume of cylinder to the respect of x. Note that we are differentiating the volume V to the respect of x. Thus, it shall be set as dV dx. To differentiate, use quotient rule, where the numerator is considered as u and denominator is considered as v. Then, differentiate accordingly and simplify. The final simplified dV dx is displayed on the screen. Now, to calculate the value of x, the differentiated volume of cylinder dV dx shall equal to 0. Hence, the value of x is obtained by simply calculating dV dx equals to 0. After simplifying, you will be left with two values of x, which is x equals to 0 and x equals to 16 2 over 3. Since the length of the rectangular paper cannot be 0, thus x equals to 0 is rejected. In a nutshell, the value of x is 16 2 over 3. In the problem statement, it is given that the volume of cylinder is maximum, which means the second order of derivative d square v over dx square is smaller than 0. Thus, to find the second order of derivative, the differentiated volume of x, dV dx, is again differentiated. To do that, we must use the quotient rule, where the numerator acts as u and the denominator acts as v. Then, differentiate accordingly and simplify. The simplified version of the second order of derivative is displayed on the screen. To prove the volume is either maximum or minimum, the value of x, which is 16 2 over 3, is substituted into the second derivative.
If the second derivative appears to be less than 0, then the volume is maximum and vice versa. In this case, the second derivative shows that it is less than 0, which means it is maximum. Thus, the volume of cylinder is proved to be maximum.
Thus, the answer shall be y equals to 25 minus x, y equals to 25 minus 50 over 3, y equals to 25 over 3 equals to 8, 1 over 3. So the final answers are length of paper 16, 2 over 3 centimeter and width of paper 8, 1 over 3 centimeter.
To sum this all up, since calculus is a study of a rate of change, that makes it important due to its huge probability because calculus is not restricted to math nor analysis. Calculus is used pretty much anywhere such as physics, chemistry, and biology. Calculus can also be used to calculate the notion of rate of change, such as to find the rate of prices can help to grow a business, while finding the rate of change of weather can help students to understand that some events in nature have a repeating pattern. All in all, calculus has a huge role in life because most profession needs the S in calculus to succeed.